So right now we're going to talk about real quickly, this is just to help you go over your project of what you need to do. These are the standards up here, what the state of Georgia asks for you to be able to know and prove that you know it. So in order for me to know that you know it, in place of a test this time, we're going to do these prove it tasks. So these I can statements come directly from the standard itself. So, for example, I can tell the difference in the structure of an atom, an ion, and an isotope. So structure has to come from up here because it says develop the structure. So that's what we're looking at. So structure means that you have to be able to draw a diagram, or that you can recognize something from a diagram and explain it when you see what an atom looks like as compared to an ion, or as compared to an isotope. So for example, now that I'm going to choose to do something really simple, I'm going to choose beryllium, which is number 4 on the periodic table. And since I'm choosing beryllium, you don't need to choose beryllium. You need to choose a different element, because you're going to choose, it says here, you're going to choose 2 different elements. So for example, the easiest thing to do on these prove it tasks is to take a sheet of notebook paper or a sheet of white paper and do each task on one page. So like I'll do this prove it task on page 1, this prove it task on page 2, page 3, 4, 5, 6, and 7. And they're really not that hard once you get into them. So this tells me I have to show examples of 2 different elements. So I'm going to show you beryllium. You may want to choose lithium and boron. They're right there beside it, so they'll be very, very similar. You're going to make a model or diagram of their regular atoms, an ion, and an isotope that are clearly labeled explaining their differences. So, for example, I may take my sheet of paper and I might divide it in 2. So I might say, okay, I'm going to put my first one, which I'm going to do beryllium, over here. And I might put my other one, maybe I choose nitrogen, and I'll do it over here. Okay? So you can do them side by side if you want to. And so what I would do is on this one, I'm going to show the regular atom, right? So my regular atom of beryllium, using my periodic table, I know that it has 4 protons, it has 4 electrons, and it has 5 neutrons. So what I'm going to do is I'm going to draw that out. So you can use different colors if you want to. You can use notations if you want to, however you want to do it. So first of all, I'm going to draw my nucleus. This is my regular atom. So in my nucleus here, I know I have 4 protons, so we can put 4p. And then I can put 5n, because my protons and neutrons are the 2 things in the nucleus, right? Then, this is my nucleus, so I'm going to label that. Okay. Now I know I've got my electron cloud, right? So my electron cloud and my electron orbitals are going to be out this way. So we usually just draw these like this. I know beryllium is in period 2, so it has 2 energy levels. Okay. And then I'm going to put my electrons out here. Remember, the first energy level can hold 2 electrons. And I have 4, right? Because I have 4 protons, I have 4 electrons. So I'm going to have 2 out here. So my regular atom of beryllium would look like this. So there's my protons and neutrons. These are my electrons, right? And I can just, if I want to abbreviate, that's fine, right? And then this whole thing out here are this is my electron cloud, right? Electron cloud. I can label that. That's talking about this whole area kind of out here where these orbitals are. Okay? So I've got my nucleus in here, right? There's my nucleus. I've got that labeled with my protons and neutrons. All right, so now that's my regular atom. So how do I change this? If I change this to an ion, okay? I know beryllium, because we talked about it in class today, but if I didn't, I would still know that an ion is going to gain or lose an electron. So I'm going to show either one. So you can decide if you want to show it gaining an electron or losing an electron, but to be accurate, since we talked about today in class, beryllium is in family 2, so beryllium normally will lose 2 electrons, okay? So I'm going to draw that. So I'm going to draw the same thing. I'm going to draw the nucleus, which in this case I have 4 protons and 5 neutrons. That did not change, did it? So there's my nucleus. All right, so out here on my electron cloud, if it's lost 2 electrons, look at what my normal one looks like. So I have 2 on that first shell and I have 2 on the outer shell. Basically, it's losing that whole outer shell, right? So I'm going to draw just one shell with 2 electrons. Those are my electrons, right? Have 2 electrons. I have beryllium with a 2+ charge that we learned about today. Okay? Because beryllium has given away 2 electrons. So it made an ion. So that's what an ion would look like. It would still have your 4 protons. It would still have 5 neutrons. But it would only have 2 electrons because it makes a +2 ion. So that's your ion of beryllium. Okay? Then if I did my isotope, come under here. This is a change in the neutrons, right? So, what I'm going to do here is I'm going to draw the same nucleus, except for 4 protons. I have to change the number of neutrons. So in this case, my electron cloud, if I'm drawing just a regular atom, it's still going to have 4 electrons because I'm not making an ion become an isotope, okay? I am making this regular atom, I'm changing it from the regular atom to the isotope. So I'm going to keep everything the same except for the number of neutrons. And if we look here, beryllium has 5 neutrons on average because 9 minus 4 gives us 5. All I would have to do is I would have to change this number to 4 neutrons, or I could change it to 6, okay, because it's just an average. Okay, so that's all I would do. That's my nucleus again. So there's my nucleus. And there's my electrons, right, that are there. And that's it. So that's how you're showing the difference between a regular atom, what it would look like as an ion, and what it would look like as an isotope. All right, the next thing we're going to look at is your next task on here. So you're going to pick an element with this test. Pick an element with the atomic number of 8 or higher and make a 3D or a 2D model. 2D model is just a drawing of its atom and its parts. So basically you're just going to pick an element with 8 or higher. So you can't pick beryllium because it doesn't have it has an atomic mass of, or atomic number of 4. So, but this is what you're going to do. You're just going to draw the basic atom and you're going to label the parts. That's all you have to do on that one. The next one, it says create a visual. So I'm on number 3, create a visual to write an explanation identifying each family group and their correct number of valence electrons. So basically, if you look at the periodic table, on our periodic table that we labeled in class, you have the number of valence electrons that are already on there. So you may do something like make a chart, make a graph. What I would probably do is I would write the family numbers, family groups here, and I would write valence electrons here. And then I would write family group 1 has 1 valence electron, and so on and so forth. So you can make a visual for that. It's very, very simple. It doesn't take long. Then the next one is I'm going to make a diagram or a chart with or I can write an explanation identifying the family group and the types of ions they can make using the correct number of valence electrons. So we did that today on the periodic table. So I would say family group 1, somehow I'm going to write this down. I don't have to remake the periodic table at all. I just have to make some sort of visual or chart that I might want to do something like this, where it says, you know, family group 1 has a 1+ oxidation number, so it makes a positive ion. Family group 2 is going to have an oxidation of number 2, So it's going to make an ion with a positive 2 charge. Families 3 through 12 are going to vary, something like that. So you might want to do a chart or something to show that you have that. So then the next one is create a visual or write an explanation identifying the 3 groups by their locations on the periodic table. So you may want to do just like a quick sketch. On our periodic table, you have the 3 groups, the metals, the nonmetals, and their metalloids. And so when we were looking at those, remember we have properties like the groups that are conductive, the groups that are semiconductors, the groups that are not conductive. Then you have between your metals, nonmetals, and metalloids, you have if they are ductile, if they're malleable or not. So those are the properties there. They're basic properties that you would place on that visual. So you could just kind of do an outline on a sheet of paper of the periodic table. You don't have to write in all of the elements, but maybe just shade basically where your metals are, basically where your semi-metals are, your metalloids, and then your non-metals there on the right, and then somehow notate those basic properties, kind of like we did on the concept map in class, okay? But you can just put the words there. On this last one here, or not the last one, but the second to the last, make a worksheet that could be used for helping students learn the elements and their states of matter at room temperature. So on your sheet of paper, you might want to have the states of matter at the top and what they are, some type of explanation, and then you may want to also have the elements that are solids, liquids, and gases. Now those are in your reading if you have the informational text. If not, I'm going to quickly show you on the periodic table. I put a G right here, hydrogen is a gas. If it doesn't have anything in the upper corner, which is all of these, that's a solid. So you'll notice that most of them are solids, okay? Mercury is a liquid at room temperature. All the rest of those are solids because they are not noted. Nitrogen over here is a gas. Those are gases. Of course, your noble gases are all gases. Here, chlorine is a gas, and there's just one other liquid, it's bromine. So those are the difference between solid, liquids, and gas. You do not have to name each solid, of course. That would be a tremendous amount of work to do, but you could just say, you could name your gases and you could name your liquids, and then you could say all the rest of them are solids in some sort of sheet or worksheet, and then you could ask some questions, multiple choice questions, or true false, or fill in the blank for matching or something like that to know that you know the difference there. So that's that one. And then the last one is you're going to create a dating advertisement like Match.com, and you're going to personify your family group elements. So your ad should identify the family group and claim which families they would most likely bond based on the octet rule and their number of valence electrons. So again, you're going to create an ad maybe for family group 1. Family group 1 is in search of somebody. They have 1 valence electron, so they need 7 more. So they are looking for somebody that's going to meet those standards. So they're going to bond with somebody from family group 7. So you can be creative and write something. So personify means you're going to actually act like they're people. So I would maybe take, I'm lithium. You could make up a name that comes from lithium or something, and you could say that, that they're in search of somebody to bond with that has 7 valence electrons. You could research lithium and its the way that it bonds with other elements from family 17 and use some characteristics of the way that bond works. But you're going to do some sort of advertisement. You could draw a picture, what lithium would look like if it was a person, and then who it's going to bond with, and maybe lithium fluoride is going to bond with fluorine, and you might want to draw a picture of fluorine and what it may look like. So you can have a little bit of fun, comic strip wise or something with that one. And so all you're going to do is you're going to look at the family groups and see which families it would most likely bond with. So that's really all that we need. And so these are 10 points apiece, and you notice down here how they'll be graded. So again, the booklet's the easiest thing to do. If you choose to do a electronic version, you can do like a slides presentation on Google Slides and just share it with me, or you can do one on PowerPoint and just email it to me. So my email is just like your email, except that I am J. Willis my initial comes first. So J Willis at irwin.k12.ga.us. So the ending is just like yours. So you can just email that to me with an attachment and put in the subject area. If you're emailing it straight to me and not sharing with me on Google, just put that it's the project. The Element Families Project would be great for the title. So I hope that helps.